Hello, good morning, good afternoon. Independent probability, last section of the chapter. Let's finish probability. Let's get going. I don't know why I'm doing this. Right, okay, so dependent probability. Dependent means that it depends, okay? So it's very similar to what you've been doing, but the trick here is that you need to be very careful because the question in the exam will not tell you, it will not tell you whether it's independent probability, which is what you've been doing so far, or dependent probability. So you need to figure that out from the wording of the question. So you need to be very careful and pay lots of attention. So when you have independent probability, basically the first event doesn't have any impact on the second event, right? So think about your deck of cards. If I take one card out, what's the probability of it being a heart? Is 1/4. If I put it back in, shuffle, and take another card out, the probability of that second card is not affected by the first card because I put it back in. I didn't change anything. However, let's say I have the deck, I shuffle it, I take one card out, and I don't put it back in. I leave that card out and then take a second one. Because I didn't put the first card back in, that would change the probabilities, isn't it? First of all, because I won't have 52 cards anymore, I will only have 51, so the probabilities change a little bit. And also because if the first card was a heart, and I take it out, and I don't put it back in, I take it out, what's the new probability of getting a heart now? Well, it's not going to be 13 out of 52. Because there's one heart less, so it's going to be 12, but out of 51, not 52, because I took one card out. Can you see what's going on there? So you need to be careful, understand it from the wording of the question. If they tell you with replacement, if you see the word replacement, that means you put the card back in or the ball back in, whatever it is. And if it says without replacement, it means that it doesn't go back in, so it gets taken out. You need to be careful with that. Or you need to understand it from the context of the question. If the question is about like this one here, then it is without replacement, and you need to use your common sense if you've got it, because I know some of you. So let's say I have 3 jam donuts and 2 chocolate donuts in the fridge, and I don't care. I want to eat 2, and I'm just gonna not looking, pick one, and another, pick one, eat it, take another one, eat it. What's the probability that both donuts are the same flavor? It doesn't say replacement in the question, but because you eat it, you're gonna put it back. It'll be disgusting if you did that, isn't it? If you ate it and put it back, we don't do that, okay? So, what would be the probability of both donuts being the same flavor? Okay, so first of all, first event is the first donut, and either it's jam with a probability of 3 out of 5, or it's chocolate with a probability of 2 out of 5. That's the first donut, isn't it? I've got 3 out of 5 and 2 out of 5. Now the second donut, right, this is where I need to be careful. If the first donut was jam, and I ate it, what's the probability of the second donut being jam? Well, it's going to be 2, because there's only 2 jam donuts left, because I ate 1 out of 4, because there's only 4 donuts left now. What's the probability of the second one being, well, if the first one was jam, the probability of the second one being chocolate would be 2, because the 2 chocolate donuts are still there, but the total is now 4. Okay? And don't copy this down because it doesn't work like that anymore. You need to be very careful. If the first donut was chocolate, what's the probability of the second one being jam? Well, it's going to be 3, because the 3 jam donuts are still there out of 4, and the probability of the second one being chocolate where there's only one chocolate donut left out of the 4. And that is correct, because if you look at it, that probability plus that probability adds up to 1, 5 over 5. These two probabilities add up to 1, 4 out of 4. And these two probabilities add up to 1 again, 4 out of 4. So the tree diagram is properly drawn, is correctly drawn. Okay. What was the probability of both donuts being the same flavor? So I'm looking for the probability of jam and jam, or, big important, the probability of being chocolate and chocolate. Okay, the probability of jam and jam is going to be that and that, and the probability of that we know is 3/5 times 2/4, which is 6 out of 20, and I'm not going to simplify, it's going to leave it there. And the probability of both donuts being chocolate is going to be chocolate and chocolate, so 2/5 times 1/4, which is 2 out of 20. So the probability of both donuts being the same flavor, I didn't care which flavor they were, it's going to be 6 out of 20 plus 2 out of 20, which is 8 out of 20, which is indeed 4 out of 10, 2 out of 5. And that would be my final answer. In the exam, sometimes if your numbers are really big, you don't have to simplify, okay? So this is dependent events, where the outcome of the first event affects the probabilities of the second one. Again, let me stress out that you may not be told necessarily in the exam whether there is replacement or not, but you need to infer it from the information. If the question is about eating donuts, as we said, you're not going to put it back. If the question is about, typically, like picking socks from a drawer, like you pick one sock and another sock, what is the chance they have the same color? Typically that's not replacement, because you want to wear 2 socks. Not what people do. That's it really. More often than not, if there is replacement, they will tell you that in the question. And typically, but not always, if they don't tell you that there is replacement, means dependent probability. I hope that makes sense. We will practice a lot of this, and yeah, you'll be fine. All right. See you next time. Bye.